Our universe is a vast and mysterious place. It is constantly expanding, getting bigger by the second. Imagine a balloon being blown up. That's pretty much how the universe behaves. This expansion began billions of years ago with a gigantic explosion called the Big Bang. Scientists observed this expansion by looking at distant galaxies. These galaxies are moving away from us. The further away they are, the faster they appear to be moving away. This observation tells us that the universe is stretching in all directions. The Big Bang Theory is the best explanation we have for the origin and evolution of the universe. It is supported by a wealth of scientific evidence, such as the cosmic microwave background. This radiation is like an echo of the Big Bang. What we see and interact with is only a tiny fraction of what is out there. The universe is mostly made up of things we can't see or touch. That's right, most of our universe is invisible. We know about the expansion of the universe and its components by observing how light and matter behave. Gravity plays a crucial role. It's the force that holds galaxies together and influences the rate at which the universe expands. When we study the motion of stars within galaxies, we find something peculiar. They move much faster than they should based on visible matter alone. This discrepancy suggests that there's more mass out there than we can see. This invisible mass is called dark matter. It doesn't emit light or interact with light, making it impossible to observe directly. But its gravitational effects are undeniable. Another clue comes from observing distant supernovae, stars that explode. These explosions are incredibly bright and uniform, acting like cosmic rulers. These measurements reveal that the expansion of the universe isn't slowing down as expected due to gravity. Instead, it's speeding up. This acceleration implies the existence of another mysterious component called dark energy. It's thought to be a form of energy inherent in the very fabric of space, counteracting gravity and pushing everything apart. Think of dark matter as the fabric of the universe. It provides the gravitational framework for galaxies to form and cluster together. Dark energy is like a repulsive force that stretches the very fabric of space and drives its accelerated expansion. But here's the most mind-blowing part. The universe is made up of about 68% dark energy, 27% dark matter, and only about 5% normal matter. That means everything we see, from stars and planets to galaxies and cosmic dust, makes up a tiny fraction of the total content of the universe. Normal matter, which is what we're made of, consists of atoms. These atoms form elements like hydrogen, helium, and everything else on the periodic table. This ordinary matter clumps together to form stars, planets, and even ourselves. But compared to the vast expanse of dark matter and dark energy, the amount of normal matter is surprisingly small. It's like a sprinkle of sugar on a giant cake. While dark matter and dark energy dominate the composition of the universe, normal matter is what makes the universe interesting. It's responsible for the formation of stars, galaxies, planets, and ultimately, life itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move apart, just like the galaxies in our expanding universe. Now imagine there's something inside the balloon, pushing the dots apart even faster. This is what dark energy is like. The balloon itself represents the fabric of space, and the air inside is like dark energy, causing the universe to expand at an accelerating rate. The dots on the balloon represent galaxies moving apart. Just as the surface of the balloon stretches and expands, the fabric of spacetime in our universe also stretches, driven by the enigmatic force of dark energy. And just like the dots on the balloon, the galaxies get taken along for the ride. Scientists are constantly working to understand these mysterious components of the universe. They build telescopes and detectors to study the cosmic microwave background. They map the distribution of galaxies and observe distant supernovae. These observations help us refine our understanding of dark matter and dark energy, constraining their properties and testing our theories. The more we learn, the more we realize how much we still don't know. The study of dark matter and dark energy is a journey into the unknown. It's a quest to understand the fundamental nature of our universe and our place in it. And while the answers are still elusive, the quest for knowledge continues to inspire and amaze us.